Moving on to the first question. ABCD is a quadrilateral in which P, Q, R and S are midpoints of sides AB, BC, CD and DA respectively, and AC is diagonal. Show that SR is parallel to AC and SR is equal to half times AC. Second, PQ is equal to SR. Third, PQRS is a parallelogram. Now moving on to the solution. He has given that ABCD is a quadrilateral in which PQR and S are midpoints of sides AB, BC, CD and DA respectively, and he also given that AC is diagonal. He asked us to prove that. First thing, SR parallel to AC and SR is equal to half AC. Second, PQ is equal to SR. And third, PQRS is a parallelogram. Now, in order to prove those, let us follow a procedure. Initially, let us consider triangle DAC. In triangle DAC, S is midpoint of DA and R is midpoint of DC. Then from midpoint theorem we can say that SR is parallel to AC and also SR will be equal to half times AC. This is what our first proof required. Now if we consider in triangle ABC, P is midpoint of AB and Q is midpoint of BC. Then from midpoint theorem we can say that PQ is equal to half times AC. Let it be as second equation. From proof 1 and equation 2 we can say as SR is equal to half AC and PQ is equal to half AC, SR is equal to PQ. This is what our second proof required. Here we can also say that from midpoint theorem PQ is also parallel to AC. Now in the first proof we got that SR is parallel to AC, and in the second proof we got that PQ is parallel to AC and PQ is equal to half AC and SR is equal to half AC. So here we can say that PQ is also parallel to SR. Now here SR is equal to PQ and PQ is parallel to SR. Here we can say that in quadrilateral PQSR, opposite sides are parallel and are equal. If in a quadrilateral opposite sides are parallel or equal, then we can say that the quadrilateral is a parallelogram. Therefore, PQRS is a parallelogram. Moving on to the second question. ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. Show that quadrilateral PQRS is a rectangle. Now moving on to solution. Given that ABCD is a rhombus in which PQRS are midpoints of sides AB, BC, CD and DA respectively. Let us draw a figure regarding it. We need to prove that PQRS is a rectangle. In order to prove this, let us follow a procedure. In the first step, let us join BD and AC. Now, let us consider the triangles, triangle PAS and triangle QCR. In these both triangles, angle A is equal to angle C, since opposite angles in a rhombus are equal, and also AS will be equal to QC. Since we know that in rhombus all the sides will be equal, S divides AD in its midpoint and Q also divides BC in its midpoint, so AS is equal to QC, and similarly AP is equal to RC. Now here in both the triangles, two corresponding sides and an included angle in between them is equal. So by SAS property we can say that triangle PAS is congruent to triangle QCR. When two triangles are congruent, we can say the corresponding sides and corresponding angles can be equated. So here let us equate PS is equal to QR. Similarly, let us consider the triangle PBQ and triangle SDR. In these two triangles, angle B is equal to angle D. Since ABCD is a rhombus, opposite angles in a rhombus will be equal. Here SD is equal to BP, since S is midpoint of AD and P is midpoint of AB, we know that AD is equal to AB, and similarly we get DR is equal to BQ. Now again by SAS property, the two triangles are similar. So triangle PBQ is similar to, here by SAS property the two triangles are congruent, that is triangle PBQ is congruent to triangle SDR. As two triangles are congruent, then their corresponding sides and corresponding angles can be equated. So here SR can be equated to PQ. In the first step we got that PS is equal to QR, and here we got that SR is equal to PQ. Two pairs of opposite sides are equal, so here we can say that PQRS is a parallelogram. As PS is parallel to RQ in triangle ADB. Now if we consider in triangle ADB, S is midpoint of AD and P is midpoint of AB. Thereby midpoint theorem we can say that PS is parallel to BD. Let us assume that the points where AC and BD intersecting, PS RQ, SR and PQ as E, F, G and H. Now we consider that PS is parallel to RQ and we got PS is parallel to BD. If we observe clearly, HSGO also forms a parallelogram. As PS is parallel to BD, we can say yes, H is equal to GO and SH is also equal to GO and HS is also parallel to GO. So we can say HSGO forms a parallelogram. As HGO forms a parallelogram, we can say in parallelogram opposite angles are equal. Therefore, angle HOG is equal to angle HSG, which is equal to 90 degrees. As angle HOG will be equal to 90 degrees since in rhombus diagonals bisect perpendicularly. So we can say here we got angle S is equal to 90 degrees. Now we know that PQRS is a parallelogram and in which one of the angle is 90 degrees. Then we can say that PQRS is a rectangle. Moving on to third question. Given that ABCD is a rectangle and PQR and S are midpoints of sides AB, BC, CD and DA respectively, show that quadrilateral PQRS is a rhombus. Now moving on to the solution. Given that ABCD is a rectangle and PQR and S are midpoints of AB, BC, CD and DA respectively, and he has asked us to prove that PQRS is a rhombus. Now let us move on to the procedure. Now in the procedure, in the first step, let us consider two triangles, that is triangle DAC and triangle BAC. Now here in triangle DAC, S is midpoint of AD and R is midpoint of DC. So here by midpoint theorem we can say that SR is parallel to AC and SR is equal to half times AC. Now in triangle BAC, P is midpoint of AB and Q is midpoint of BC. So here by midpoint theorem we can say that PQ is parallel to AC and PQ will be half times AC. In the initially when we consider triangle DAC, we got that SR is equal to half AC and here we got PQ is equal to half AC. So we can say SR is equal to PQ. Now in quadrilateral PQRS, two opposite sides are equal and here we get another condition, that is SR is also parallel to PQ. Here now in the quadrilateral PQRS, we got the condition that opposite sides are parallel and are equal. So we can say PQRS is now a parallelogram. Here, in order to prove that PQRS is a rhombus, let us consider the two triangles, that is triangle PAS and triangle PQB. In these two triangles, angle SAP is equal to angle QBP is equal to 90 degrees, as ABCD is a rectangle, and AP is equal to PB since P is midpoint of AB. Now, as ABCD is a rectangle, AD is equal to BC, and as S is midpoint of AD and Q is midpoint of BC, we can say here AS is equal to BQ. Now here in triangle PAS and triangle PBQ, according to SAS property, the two triangles are congruent. That is, triangle PAS is congruent to triangle PQB. When two triangles are congruent, we can say that the corresponding sides and corresponding angles will be equal. Therefore here PS will be equal to PQ. Now in parallelogram PQRS, we have got that adjacent sides are equal. Here we know that a parallelogram with adjacent sides equal is a rhombus. Therefore we can say PQRS is a rhombus. Moving on to fifth question. In a parallelogram ABCD, E and F are the midpoints of sides AB and CD respectively. Show that line segments AF and EC trisect the diagonal BD. Now moving on to solution. Given that ABCD is a parallelogram in which E is midpoint of AB and F is midpoint of CD, and we are required to prove that line segments AF and EC trisect BD. So here if we observe, AF intersects BD in P and EC intersects BD in Q. If AF and EC trisect the line segment BD, then we need to prove that PD is equal to PQ is equal to QB. Now in order to prove this, let us move on to the proof. That is, he has given that ABCD is a parallelogram, so we can say that AB is parallel to CD and AB is equal to CD. As in a parallelogram, opposite sides will be equal and parallel. Now let us multiply this by half, then we get half AB is equal to half CD. If we observe the figure, he has given that F is midpoint of CD, so we can say half CD is nothing but FC, and as E is midpoint of AB given, we can say AE is equal to FC. As AE is equal to FC and we know that AB is parallel to CD and the part of AB and part of CD also will be parallel. So here we can say AE is also parallel to FC. Now if we consider the quadrilateral AEFC, in this one pair of opposite sides are parallel and equal. So we can say AEFC is a parallelogram. Now let us consider the triangle DQC. In triangle DQC, we know that F is midpoint of DC, which is given, and we know that AECF is a parallelogram. Thereby we can say that AF is parallel to EC, which further implies that part of AF, that is PF, is also parallel to QC, that is part of EC. Now as in triangle DQC, F is midpoint of DC and PF is parallel to QC, By converse of midpoint theorem, we can say that P is midpoint of DQ. As P is midpoint of DQ, we can say DP is equal to PQ. Let it be as equation number 1. Now, let us consider the another triangle. In triangle APB, E is midpoint of AB, and as AFCE is a parallelogram, we can say AF is parallel to EC, which further implies that part of AF, that is AP, is parallel to part of EC, that is EQ. Now in triangle APB, as EQ is parallel to AP and E is midpoint of AB, by converse of midpoint theorem we can say that Q is midpoint of BQ. As Q is midpoint of BQ, we can say that PQ is equal to QB. Let it be as equation number 2. Now by observing equation 1 and 2, we can say that DP is equal to PQ, which is further equal to QB. Therefore we can say that AF and EC trisects line segment BD. This is what our proof required. Moving on to 6th question. Show that line segments joining midpoints of opposite sides of a quadrilateral bisect each other. Now moving on to solution. Let us assume a quadrilateral ABCD in which P, Q, R, S be the midpoints of sides AB, BC, CD and DA respectively. Let us note them. Now we are required to prove that line segments joining midpoints of opposite sides bisect each other, that is QS and PR bisect each other. Now in order to prove this, let us join PQ, QR, SR and PS such that PQRS form a quadrilateral. Now let us also join the diagonals of quadrilateral, that is AC and BD. Now let us consider the triangle ABC. In triangle ABC, we know that P is midpoint of AB and Q is midpoint of BC. Then by midpoint theorem we can say that PQ is parallel to AC and PQ is equal to half AC. Let it be as first statement. Now similarly, if we consider in triangle ADC, S is midpoint of AD and R is midpoint of DC. Now as S is midpoint of AD and R is midpoint of DC, we can say that by midpoint theorem SR is parallel to AC and SR is equal to half times AC. Let it be as second statement. Now by first statement and second statement we can say that PQ is parallel to SR and PQ is equal to SR. Now, if we observe in quadrilateral PQSR, a pair of opposite sides are parallel and are equal. Therefore, we can say that PQSR is a parallelogram. Now, in the parallelogram, if we consider PR and QS, they are diagonals. We know that in parallelogram diagonals bisect each other. We can say PR and SQ bisect each other. This is what our required proof. Moving on to 7th problem. ABC is a right angle triangle at C. A line through the midpoint M of a hypotenuse AB and parallel to BC intersects AC at D. Show that first one, D is midpoint of AC. Second thing, MD is perpendicular to AC. And third thing, CM is equal to MA is equal to half AB. Now moving on to the solution. Given that ABC is a triangle, right angled at C. Now here let ABC be the given triangle according to the given information. He says that M is a midpoint of hypotenuse, let it be here, and he also says that a line through midpoint of M of hypotenuse AB is drawn parallel to BC. That means let us assume that a line passing through M and parallel to BC, and he says that it intersects AC at D. This is the required figure for us. We need to show that D is midpoint of AC, and second thing, MD is perpendicular to AC, which means we have to show that angle MDC is equal to 90 degrees. And third thing, CM is equal to MA is equal to half AB. Now moving on to procedure. In this, let us consider triangle ABC. In triangle ABC, we know that M is midpoint of AB, and he says that a line through midpoint M of hypotenuse AB and parallel to BC intersects AC at D. So we can say that MD is parallel to BC. As M is midpoint of AB and MD is parallel to BC, we can say that by converse of midpoint theorem, D is midpoint of AC. This is what our first proof required. Now we know that DM is parallel to CB, and let us consider CD as transversal. When DM is parallel to CB and CD is transversal, angle MDC and angle C lie on the same side of transversal interiorly. We know that sum of angles lying on the same side of transversal interiorly is 180 degrees. We can say angle MDC plus angle C is equal to 180 degrees, which implies angle MDC plus angle C is nothing but 90 degrees, as ABC is a right angle triangle at C, that is equal to 180 degrees. That implies angle MDC is equal to 180 degrees minus 90 degrees, which is equal to 90 degrees. Therefore, we can say that MD is perpendicular to AC. This is what our second proof required. Now let us join CM. Now if we observe the triangle AMC in this, MD is dropped perpendicular to AC. So we can say that angle ADM will be also 90 degrees. Now let us consider both triangles, that is triangle MDC and triangle MDA. In these two triangles, angle ADM is equal to angle CDM is equal to 90 degrees and AD is equal to DC, since we got that D is the midpoint of AC and here DM is the common side for both the triangles. Now hereby SAS rule of congruency, we can say triangle MDC is congruent to triangle MDA. When two triangles are congruent, then their corresponding sides and angles can be equated. Therefore, we can say that MC here can be equated to MA. In the above, we got that MC is equal to MA. Now, in the first step, he has given that M is midpoint of hypotenuse AB. So we can say that MA is equal to MB, which is equal to half times AB. Now we know that MA is equal to half times AB and MA is equal to MC. From these two we can say that MA is equal to MC, or MC is nothing but CM, which is equal to half times AB. Therefore finally we can write this as CM is equal to MA is equal to half AB. This is what our third proof required.